In this slide, we will talk about magnetic field around the body. And for example, when we want to record ECG from a body, you have an electrocardiograph here, two lead wire connected to the body, and because of this a shaded region, shaded area, and the magnetic field B, we have a current flow this conductive region, and it leads to bad effect on our ECG's input and bad effect of voltage at the output of the recorded signal. Also, the change in magnetic field will change the output voltage. For reducing this bad effect, we should reduce, first of all, if we can reduce the B, the magnetic field, but usually the magnetic field is not under our control. Therefore, we should minimize other parameters to minimize the bad effect of magnetic field surrounding the body. For this purpose, we can reduce the area by twisting the lead wires together and keeping them close to the body in order to reduce the effective area. Overall, we have three choices: reducing the magnetic field, keeping the electrocardiograph and leads away from potential magnetic field regions, but these choices are not completely under our control, and only the third one, reducing the effective area of the single turn coil by twisting the lead wires, is in our hand, and we will use twisted lead wires or using some special cables with minimum area, and these three items will help us to reduce the bad interference of magnetic field around the body. Another important issue which should be considered is transient protection. The isolation circuits are primarily for the protection of the patient, in that they eliminate the hazard of electric shock resulting from interacting among the patient, the electrocardiograph, and other electric devices in patient's environment. For example, in the operation suite, EEG monitoring, and electrosurgical unit ESO applications. If the ground connection to the ESU is faulty, or if higher than normal resistance is present, the patient's voltage with respect to ground can become quite high during coagulation or cutting. This high potential enter the electrocardiograph or cardiac monitor and can be large enough to damage the electronic circuits. To reduce this effect, we use some parallel silicon diodes, Zener diodes, and gas discharge tubes, as you can see in this figure. And this is the protection for the transient high voltage. As I told you before, we can minimize the interference of magnetic field by trying to eliminate the source of the signals via shielding techniques. The type of shieldings is ineffective for magnetic fields unless the metal panels have a high permeability. It means that good magnetic and also electric conduction are needed to the required reduction. But today, high quality differential instrumentation amplifiers with high CMRR make such shielding unnecessary. In the previous version of this book, we have a figure like this, and in the new version of Webster's book, he removed this figure, and instead of that, he preferred to use good amplifier with high CMRR. Another important part of a recording system, especially for ECG, is right leg driver. In most modern electrocardiographic system, the patient is not grounded at all. Instead, the right leg electrode is connected. As I told you before, all the applied bad voltage on our body, we called it common mode voltage, and as I mentioned before, we can assume that whole body is a single node in this perspective. Can be used this voltage can be used to remove itself. It is an interesting method. The common mode voltage on the body is sensed by the two averaging resistor RA and RAs, you can see here, and amplified and fed back to the right leg. If we have weak common mode on the body, we will generate a negative weak common mode and fed it back to the right leg, to the body, and these signals will remove each other. The negative feedback drives the common mode voltage to a low value, and we call this system right leg drive. This is a good system to generate a virtual ground, because this driver will remove all the common mode on the body and the overall voltage on the body will be zero.